Have you ever hit a wall? You know, a digital wall made of so much data that your most powerful computers just grind to a halt? Well, back in the 1990s, that wasn't science fiction. It was a daily crisis for big businesses. The solution? A truly brilliant strategy of divide and conquer. That, and this is no exaggeration, changed everything.
So let's start with a question that pretty much every growing company has to face sooner or later. What on earth do you do when your data starts growing way faster than your database can possibly handle it?
And look, this wasn't some theoretical problem. By the 90s, companies were literally drowning in data. This whole dream of being a data-driven business was fast becoming a nightmare because their databases, which were trying to do everything one step at a time, were just stopping. They were hitting a digital brick wall, and it put the entire system at risk.
But you know, when you hit a wall, you don't just throw your hands up. You get creative. And Oracle's answer was this revolutionary new approach. An idea so simple in concept, yet so incredibly powerful it would redefine high-performance computing. It was a true divide-and-conquer strategy.
So what was this thing? It was a feature called Parallel Query. And the core idea behind it was just brilliant. Think of it like this. Instead of having one person try to build a whole skyscraper by themselves, you get 100 workers, and you have them all build different floors at the exact same time. Oracle figured out how to split one gigantic database job into lots of smaller pieces and have them all run at once. They were attacking the problem from all sides.
To really appreciate just how big a deal this was, you have to remember the old way. Imagine trying to find one specific name in a phone book the size of a car. A single process had to read every single line one by one. For these huge company databases, that meant a single query could take hours or sometimes even days. It was just agonizingly slow and so inefficient.
The parallel query method, on the other hand, was just beautifully simple. Step 1, it divides the work. It breaks that huge task down into small, manageable chunks. Step 2, it processes all those chunks in parallel, using multiple CPUs all at the same time. And finally, step 3, it combines all the results back together. It's this elegant little three-step dance that completely changed the game.
Okay, so we get what it is, but how did it actually work under the hood? Let's dive into the core mechanics of this incredibly powerful feature.
Now, here's what was so smart about this. Oracle didn't just fix one thing. No, they went after all the major bottlenecks. They introduced parallel table scans, which made reading data lightning fast. They created parallel joins to connect data from multiple tables at once. They even made data manipulation, inserts, updates, deletes, parallel, so you could change huge data sets in a flash. Even building an index, which was always this slow, painful process, was suddenly turbocharged. Every single one of these was a game changer on its own.
But here's the thing. This wasn't some one-and-done invention. Parallel query was an idea that grew. It matured over time. It started out as this really powerful feature, but it evolved into a fundamental part of the database's architecture.
You can really see that journey right here on this timeline. It started out pretty basic in 1992 with Oracle 7, really just focusing on those big table scans. Then, with Oracle 8, it got way more powerful, adding DML and indexing to the mix. But honestly, the real magic started happening with 9 High and 10G. The database itself got intelligent. It could now decide for you when it was a good idea to use parallelism. It went from a tool you had to turn on yourself to a smart assistant working for you in the background. And by 11G, it was so advanced it could adapt on the fly. It became this core, intelligent part of the system.
So, all of this evolution built this incredible legacy of high performance. But why did that matter so much? I mean, what was the real-world impact of all this cool tech?
This says it all, right? For companies that were trying to analyze massive amounts of data, what used to be a multi-day waiting game suddenly became a task you could knock out in a single afternoon. This wasn't just a little improvement, it was a total revolution.
And that is not an exaggeration. The ability to run these huge, complex, analytical workloads in a matter of hours instead of days is really what unlocked the whole field of business intelligence on a grand scale. It gave businesses the power to ask much bigger questions and get the answers fast enough to actually do something with them.
So yeah, the long-term impact was just massive. First off, it transformed Oracle into a true enterprise-scale database, one that could handle the biggest datasets in the world no problem. Second, you could argue it enabled the entire field of large-scale business analytics as we know it today. And finally, it became an absolute cornerstone of Oracle's reputation for high performance, a reputation that, let's be honest, continues to this day.
So when you look back at it, parallel query wasn't just another feature. It was Oracle's answer to the data explosion. It was this powerful weapon that let businesses finally conquer these mountains of data with incredible speed and precision.
Parallel query solved the critical scaling problem of its time by teaching the database how to divide and conquer. Which leaves us with one last thought to chew on. Now that data is more distributed and more complex than ever before, what's the next great bottleneck that we all need to conquer?